Thank you for having us, presenting the SCS Central API to you. Yeah, as announced, it's the one endpoint for everyday's business. And we're pleased to show you the work we've done so far and, yeah, what the current status is. So for the talk, I will give a short motivation and give you some of the history, what we were doing and what we're thinking of when designing the central API, and then concluding with the demo of what is present as of now. So without further ado, let's go on with the motivation. And our main motivation really was thinking for developer teams that user experience is key. And with that, we mean that developer teams really should have an easy way of doing their work, using a cloud platform, managing resources, and that's really our main goal that we want to achieve with this. And currently, the way of managing cloud resources is basically we have a user, and maybe a user wants to change something in the IDP, so it needs to use the API of the IDP, issuing some API requests in some way via, I don't know, Terraform or via a web portal, something like that. And the changes will be made in the IDP. Same for OpenStack resources. We there use the OpenStack API, or if we want to manage Kubernetes clusters, then we use the API used to manage Kubernetes clusters. May it be Gardener or may it be Cluster API. And this leads to numerous issues that makes it not so easy for developer teams. Like, for example, each of those APIs have their own authorization and authentication, and also resources like Kubernetes clusters look not very much like resources, for example, in OpenStack. And for this, we want to design a central way of managing things, and things are cloud resources. And in this way, we wanted to create the central API that a user can leverage to manage all cloud resources, may it be managing users in the IDP, managing OpenStack resources like VMs, or provisioning Kubernetes clusters. And we had multiple approaches how to solve this problem. And some of those I want to shortly present. The first of one is a real basic one. It's more like, okay, we need to create some RESTful server in some web framework and its ecosystem. But that also leads to a lot of work, as we need to implement resource models, we need to implement authentication and authorization, and also the multi-tenancy, as there are several tenants in the cloud and DevOps teams, and all this needs to be rock solid and also secure. And building everything from scratch is possible, but it leads to a real amount of effort. And therefore, we thought of another approach, leveraging OpenStack APIs and OpenStack and implementing it as OpenStack API drivers. So there we could use the existing OpenStack API as the API front end, which would save us quite an amount of work. And it was mainly implementing those drivers. A similar approach was done by Vexos with the Magnum Cluster API approach. Also, implementing those drivers is also quite an effort we need to do. And therefore, another approach was taken into consideration, which was using the Kubernetes API. And the benefits of Kubernetes is it's a really widely adopted and mature API that has really a large community, as it's one of the biggest open source projects. It has a native notion of what a resource is, which is very much in favor for us. And also it comes with authentication and also authorization via Kubernetes RBAC. What's missing is the multi-tenancy approach, which we are doing with Crossplane. Crossplane is a tool for basically platform engineering. And this will be our tool of choice handling cloud resources and also setting up the multi-tenancy and tenant separation via namespaces. So when comparing all those approaches, we see the self-defined APIs is really a lot of self-made stuff. For the OpenStack APIs, there's quite a lot we can use, which is already there, like Keystone, but we need to think of how we integrate everything. And then for our Kubernetes approach, we have the Kubernetes API server, which is already there. We have all the authentication methods Kubernetes offers or we can use with Kubernetes. As already mentioned, we have the Kubernetes RBAC for authorization and Crossplane for the multi-tenancy part. And when we go even deeper into the analysis, the amount of work really is not foreseeable for the first two approaches. And for the Kubernetes and Crossplane approach, we are already utilizing existing concepts. For the actual cloud resources, we also don't need to do much as we can use the existing Crossplane providers. And it has really a huge ecosystem to build on. And the one downside might be the scalability as we scale with namespaces in a cluster. But overall, we choose the Kubernetes and Crossplane approach. And how this is done, we can show you in the short demo that is provided by Joshua.
I hope it's going to be kind of short. I will present it using a completely plain new GitHub code space. So everyone may be following along, or the results should be kind of reproducible. So I'm opening up that right now. And also the scalability concern about Kubernetes and Crossplane is actually something that might be addressed at a later stage because there are people working on KCP and trying to make Kubernetes more scalable in the terms that which we actually would benefit from. Okay, so the code space should be ready right now. I will just need to create or install some local tooling, which can be done conveniently over a makefile. But in the meantime, while that's doing the installation, I can maybe show the Crossplane documentation a bit. that here is documentation on cross-plane I/O, and cross-plane builds upon the Kubernetes API server, and it does so using certain concepts that build on the basic Kubernetes CRDs, etc., and custom resource definitions, using composites resource definitions. At the one hand, we want to have a very simple API. Yeah, now to how we want to use these concepts from Crossplane. At the one hand, we want to have a very simple API that a user, in this case, app team, can use. Because as Oliver said, actually Crossplane is a tool for platform engineering, and we are going to use it in a very specific way. So in our case, this claim here is basically the API the user can use. And Crossplane does model, or allows rather, to model any resource in any big backend API. For example, there's this provider OpenStack provider, which models every OpenStack resource that's available into a Kubernetes resource. For example, we've got an instance here, which is just an OpenStack instance. In this terminal, I'm gonna install more dependencies. Yeah, and the OpenStack resources, which I just show in the marketplace from Upbound, is basically this resource block here, managed resource. These are basically the physical resources which map one-to-one to API resources, for example, in the OpenStack backend. Now, for the OpenStack backend, we actually don't want to create an abstraction that changes the parameters of the resource. We want to just mirror the parameters of these OpenStack resources and expose them to the API consumer directly, or mirror the APIs that are already existent. So we will have a composite resource that matches that creates an API for each managed resource, which I just did show, and it will create a composition for each one. For the Kubernetes cluster use case, where we have basically two backends we want to show, Gardener and Cluster API. We are gonna have two distinct compositions for one claim, or a user-facing API. Yeah, and now back to the demo. Now I've installed some tooling. I'm gonna also create a local dev cluster here, which is just creating a kind cluster, and we'll install Crossplane into it. This will be when the next concept of Crossplane comes into place, configuration packages. Configuration packages are basically a way to distribute compositions and composite resource definitions, also called XRDs. And these are defined in the central API repository in the Crossplane config subdirectory. For Kubernetes, we've got the API definition right here. Right now, it only allows to set the Kubernetes version, nothing more. And the composites will depend on how the cluster actually is implemented, whether using Gardener or Cluster API. And then the provider may have also some more specific needs. For example, they want to set some special cluster API fields or something. Originally, we also put the compositions into the configuration package, but sometimes the compositions did contain some implementation details, which ideally we would be able to eliminate. But for the meantime, we just packaged the composite resource definition. So basically, the definition of the user-facing API, which may be implemented by any composition. But I guess we will start with OpenStack, where we just want to mirror the OpenStack provider to be a user-facing API. And we did actually, if you take a look at that Makefile, we have the OpenStack configuration package pushed into the SCS registry as R7 tech preview here. And yeah, as that's already built and pushed, we as a user basically can now go ahead and install it. I conveniently also already prepared an make target for that. Here we go. Now I installed, using the crossplane CLI, the OpenStack and Kubernetes configuration package, which will now create many XRDs, in particular for the OpenStack configuration package, because it covers basically all OpenStack resources. We can see that the Kubernetes API provider, configuration package is already installed because it was just a single XRD. For OpenStack, it's installed now. Yeah. And now we can just follow the documentation here a bit. We already did that. We installed a configuration package. And now, now regarding the use case is basically we want to create a single central API cluster. And for each tenant, we can create a namespace in this cluster. In the OpenStack case, the tenant should get access to the cluster to their namespace. For example, we can name this tenant A. And in order for the central API cluster to do anything in the backing OpenStack API, there will be credentials which are required. So for each tenant, we will also provision a provider config with the same name as the namespace, which is due to the way we are doing cross-plane multi-tenancy. And we are gonna map the namespace to the provider config here. And yeah, the credentials are referenced here. We are probably also naming them tenant A, clouds YAML, JSON would be correct actually. Yeah, from a secret which will look like that in the cross-plane system namespace. I already prepared a secret for the GX SCS OpenStack environment, which I will paste into this code space. So I will just stop sharing here, and I'm gonna share again. I also renamed just this credential here. I created out of band this file, which contains a Kubernetes secret, which we will just apply right now. All right, so we basically just have to create these things. We're going to create a namespace tenant A, and a provider config, which I'm just gonna apply that way. And voila, we've got the provider config created for OpenStack. And now, as a basically optional step, but it will demonstrate quite well the use case for the users, we will also create a cluster role. Which is the role we can give the tenant in their respective namespace. We can create a service account in the tenant namespace, also naming them tenant A. Usually in a production setup, we would do authentication, of course, using OpenID Connect or something like that. Here in this demonstration, I will just set up a service account which will behave as the identity of the tenant. And then we can give that tenant permissions in their namespace to do as they wish with their resources. Here we go. And now as, thank you. Now as the tenant, we can actually take a look at our own namespace, but also only at stuff in the api.scs.community group, not at other resources like pods, for example. And now I prepared, or I guess we are gonna do it from scratch. We've got the example here. I, as a user, may want to create just an OpenStack VM now, instance v2. And we're gonna just take this example here, correct the namespace, and also which is something I forgot to add back in here when I tested that. It's gonna need a network. In this case, we're gonna use GXSCS, and here we Gonicus project, and inside the Gonicus project, the default network. I guess that's the default network. We can, of course, maybe just create an SSH key. and put it into there. And now, as a user, we can just look up in the documentation of an OpenStack provider what resources we want to have, and all the attributes that are documented there we can directly use here in the mirrored API under the API version API SCS community. I guess I did not oversee anything more. And we may just apply that then. Maybe even as the tenant, with the identity of a tenant, with the impersonated identity of a tenant. Looks right about right. Yeah, and we just created in the claim side of things, remember, this model here, we just created a claim basically for a mirrored API that's actually coming from the provider itself. So it will actually then create an actual OpenStack physical or managed resource, as Crossplane calls it. And we can first look how our key pair is doing, for example. That is not ready. But doesn't matter, we're just gonna delete those two again and just use another name. Okay. Third time's a charm, I guess. In a production central API environment, of course, you wouldn't have multiple central APIs. So the specific error condition shouldn't appear that often. Here we go. We can again look at the key pairs. It's synced but not ready. Now it is ready. And we can also take a look at the managed resource, which now completes already. If we now, for example, look at the actual OpenStack cloud, in here, we can see that the key pair is created. This one here, that one I created beforehand. Yeah, and also ideally the instance should be created now with this key pair attached to it. Sorry for the German, by the way. Didn't think of that. Here we go. Testing VM2 with the key pair admin2. So right now we are able to provision OpenStack resources using the Kubernetes API and that in a mirrored fashion and in a multi-tenant fashion. Of course, if it would only be the OpenStack API, that wouldn't using the Essential API wouldn't make much sense. So we also want to have other types of resources. But I don't know actually if the time is sufficient for that and Q&A. So yeah, here we go. I would, I guess, start with the Gardner or CAPI definition. I know probably we'll start with a Gardner one. Yeah, for the OpenStack stuff, we generated our composite resource definitions from the managed resource definitions. In here, we have this single handwritten, very, very short composite resource definition defining an API.scs community cluster with a single parameter, the version. So we do already have this XRD installed. These two here, I think, are actually mirrored from OpenStack because they also have a cluster. I guess that's a Magnum API. But yeah, that's our XRD that is installed, but it doesn't have any composition assigned to it. So if I would create any claim or instance of such cluster, nothing would happen really, which is where we will take a look into the how-to directory and take a look at Gardener here. And same for OpenStack, we need to have a provider config, which will create a cluster object or shoot object driver in a remote Gardener API. And we will need to have the composition, yeah, which basically is just a simple, which basically embeds a simple Gardener shoot object, starting from here. The only thing that's taken from the definition here is the version. And this is going to be patched at some occurrences, for example, here. Yeah. Yeah, the Kubernetes version is going to be passed inside of the Gardener shoot YAML. The patches are defined here. I'm not going to go into much detail how this works. That's just basic cross-plane patterns. Actually, cross-plane also has novel concepts of functions, so more complex stuff could also be implemented. For example, if we had a string here and we wanted to generate our version string somehow other than plain into it, we could do so. Yeah, so 2 steps. First, we're gonna apply the shoot composition. How to Kate's Gardner shoot composition. And then we will need also a provider config, which I will again, without screen share, just paste into here. In this case, we are gonna use the Regio Gardner for that. So we're gonna create a secret generic called tenant a Regio kubeconfig from file Gartner secret. Probably need to do this in the right namespace. So. Yeah, and then we can create a provider config. In that case, we can also call that tenant A and reference tenant A regio kube config. Those provider configs will not clash as they are in a different API version. Here we go. I hope I didn't make any typos in here. And then actually we can already create a cluster claim, which is very, very simple because it only has a single parameter. I actually prepared this beforehand. Just looks that way. It is a simple cluster resource of type SCS community, API SCS community cluster. I named it shortly because Gartner doesn't like huge names. And it has the version attribute. And right now, I made the error to deploy it in the wrong namespace, which we're gonna fix. And now we should be seeing right about the same as we did with the OpenStack resources. So we can take a look at the cluster. It is synced and ready, which means that the actual object which is backing the cluster according to the composite resource, to the composite, sorry, is already also synced and ready. Yeah, and now I might just open up the Gartner dashboard. And then here we go. We can also see that the cluster with name cluster is being created. Yeah, of course, only the version is really configurable. And this is actually the part which is will be the hardest to pull off in a sensible fashion to really abstract away multiple things from multiple implementations. But yeah, the API machinery, as I just did show, works in that kind of abstraction. Yeah, and we could also create a cluster, ideally from the same cluster definition into a central cluster API management cluster. I guess that's the end of it, unless I would, I don't think the time would suffice for a cluster API implementation as well.
The only way to know about is to ask. Is anybody interested in a showcase of cluster API demonstration?
It will probably take longer than 4 minutes.
Probably, yes.
But it's the same workflow, so.
Okay, do you have now any questions or remarks or additions?